Hey guys, how's it going? This is going to be kind of a fun video. There's not a whole lot of education going into this one, but I want to talk about some of the fun projects we've been on. Projects can be chaos with those unknown variables that are underneath the ground until you start going, whether it's piering or polymer or concrete or caissons or it doesn't matter what sort of underpinning system you get into. Sometimes you just run into issues, right? And sometimes those are attributed to not having the engineering done properly beforehand, and sometimes they're attributed to just those unknown variables, you know? So I just want to talk about a couple of the projects, a few of them. I'm not going to go more than 10, but they were fun things, you know? Like one of the projects that we had was up in San Jose. It was your standard, typical house was settling, looked like it was attributed to drainage, whatever. And this was back in the day when we used to write into our contracts, we would guarantee a lift to within the industry standards, right? So of course, when we get there, we're having issues trying to lift it using polymer or whatever. So we drive these push piers underneath this foundation footing. It was a deepened grade beam footing. And you get the idea of push piers, right? You push them as deep as they need to go until they push upward on the house and picks it up. We put these push piers on, and we're driving these 3.5 inches, I think they were, 3.5 inch diameter tubes up to 5,500 PSI per pier, and we could not lift the house. There was no caissons on the underside of it that was holding it down. There was no hydrostatic pressure that was sucking it in or holding it underground. We had 4 different engineering firms look at it, and we could not drive this single dinky little single story wood frame home to lift using the piering system that provides the best possible lifting opportunity, right? So that was up in San Jose, kind of a crazy little system there. We also had a project in Wachuka, Arizona. I had mentioned that a long while ago. Wachuka. This is where we learned about Libby Gulch clays. It's a very specific type of clay soil that's very difficult to navigate. And we had originally gone all the way out to Arizona from our home base over in San Bernardino, California, roughly. And we went all the way to Arizona with these polymer rigs and tried to shoot underneath the house, and we couldn't successfully lift. Turns out the Libby Gulch was a super expansive and super strong clay. So the polymer didn't do a whole lot. In order to help that, you don't get a lot of infiltration when you get too high of a PI. So we went out there with push piers, leveled the house out, took off, and a couple months later, clients calls us back and there's more problems. So we had one specific engineer, I think it was, he went out there and he says, oh, no, you gotta do this with helical piers. So the company I was with actually had to foot the bill to put helical piers in after push piers, after polymer, and that didn't work either. It just wound up being a crazy project, right? So those are sort of the weird things that I'm gonna talk about. And you know, if you guys have any fun stories, please feel free to drop below. This is just, like I said, gonna be a fun video. Going into it, I love Parump. I love Parump, Nevada. It's amazing. They have this wild soil profile that goes across the whole city, and just the wildest things happen, right? So Parump is one of my favorite places to be. Usually we end up doing push pier systems, helical pier systems over there. You can do polymer also. It's sort of it's tough. Okay, if you do it right, it's good. But other than that, it's tough to get right. An example, we're using these push pier systems. So again, the push piers, they rely on the weight of the structure, right? To go deep, you just keep pushing until you get lift. And at the time, I was a production manager. I was reviewing all of the dailies that came in and kind of watching the logs and stuff. And this is where that depth clause comes into play, right, guys? So they're pushing these piers, and on this one wall on the piers, they had 19 feet, 22 feet, 19 feet, 217 feet, 22 feet, 16 feet. What? It was the only thing that we could figure out is he hit a cave that was under there. Nobody really figured out exactly what happened when you're pushing a 3-inch steel tube straight down and it just disappeared. It was crazy. I thought it was a clerical error. It was not. That was also the time when I got a call from a buddy of mine who's pushing piers up in Parump and they had pushed it like 200 feet deep again. And so the guys are doing their operations, right? And they're pushing or whatever. And pretty soon the neighbor comes over, knocks on the door and says, hey, you guys doing something, footing or whatever? Like, yeah, you know, that's what we're doing, steel and blah, blah. I go, oh, well, I think that's yours. And so the guys go look over, and somehow this pier that's put at an 89-degree angle had gone down into the ground, looped around, and came all the way back up into the neighbor's backyard. I don't know how to explain that, like engineering-wise. They had to hit something and then drive it hard enough to bend the steel into a U shape to continue advancing, and then break everything on the way in order to achieve that. It was wild, right? So it's kind of another fun project, and that's the thing, like, I like Parump. Parump is fun. It's a lot of fun to be there. One of those things that is not attributed to the company that I was working with was a project that we did up in, well, a project that I looked at in La Habra. I made mention to this a while ago, so remember that thing, important to pick your contractors and watch your contracts and all that fun stuff. There was a project in La Habra I looked at, and the homeowner's home had settled 4 inches. And they did the engineering and they did all the steps, and they found that bedrock was supposed to be about 30 feet deep. And they were going to obviously embed caissons at least 3 to 5 feet into bedrock in order to stabilize everything, right? And so this was the design or whatever, but the contractor who installed the caissons, they go out there and they drill and drive and drop the cage and do everything. They go down 25 feet. So you have these 5 feet of unrestrained fill, not unrestrained fill, just weaker soil that's not bedrock, above bedrock. And then you put all of this concrete and rebar. And then you attached it to the footing. And you added the weight of the home onto all that. And they basically just acted like anchors. They like ripped the house down. I honestly felt really, really bad for this homeowner. From the time she had finished the caissons to when I went out there, it had only been a couple months. And between those 2 times, it had settled about 19 inches. Had this big cantilever crack right through her house, and it was like ripping the house downhill. It was just, it was a bad one. It was a bad one. But that's kind of like this project that we had up in National City. Well, down in National City. I remember we did this job, we went through the engineering, we did the field investigation, we did all the things, and it was good and whatever, and it wasn't supposed to be a problem. And when we got onto the job, the guys started digging the footing, and they dug down and down and down and down and down. So there's a little, picture this, like little dinky, like 1,000 square foot maybe, single story wood frame stucco structure. You got the asphalt A-frame roof. Just, it's a very lightweight structure, right? The footing on this thing was like 10 feet deep, like straight down. No basement. I'm not saying there was a basement that there was access to. I'm saying it was a 10-foot deep solid chunk of concrete that they had to get underneath. That went down and then out about 7 feet before finally the guys were like, let's go get an excavator. We're not doing this by hand. Like, absolutely crazy project up there in National City. Kind of fun, just another one of those things. We had a project in Northern California. Just a couple more, guys, I promise. Like I said, it's a brief video, it's fun. Had a project up in Northern California. There was a culvert underneath a freeway. I'm gonna call it Freeway NorCal. Yep, that was bad. NorCal. And so the nature of polymer is that when it travels, you know, it goes in as a liquid and then it expands, becomes a solid form. So oftentimes when you're operating around culverts and stuff like that, you have to drive a camera to the inside and make sure you're not filling up the culverts and doing all this fun jazz. Generally not a problem if you can clear it out within 15 minutes, right? But if it starts to set, it becomes a royal pain in the butt. So we're on this project underneath the freeway up in NorCal, and the camera moves past a crack that nobody saw, and the polymer infiltrates in there, expands and solidifies and traps the camera. But we didn't know it, right? So the guys are shooting up top or whatever and doing their thing, and eventually when we try to pull the camera out, it doesn't come out. We end up losing the camera inside the culvert. It's like, So for the remainder of this several week-long project, myself and 2 other individuals had to crawl into the smallest culvert I have ever had to work in, which was only 19 inches in diameter. So you can imagine we got like all our PPE, right, and our confined space stuff, and we're going down, and you're up there, and you can't even draw your elbows into your chest at that point. You're just up there, and you're shimmying through this 19-inch diameter culvert with air blowing and stuff. You got to try and dig out this polymer. And it was even funnier because we're in there and we're cutting out the polymer, right, and doing our thing, and we're being successful. And when we got through some of the bottom of it, it starts pushing the water from under the culvert out. And one of the guys hadn't realized he had this electric roto hammer, and he's laying in water. And so, like, every time he presses the button, he shocks himself, and he couldn't figure out why. And us guys are up top just listening to him. It's, it was bad, but it was fun. Okay, it was fun. Had a project in Palm Springs. Went ahead and did again another roadway and stuff like that. Wound up plugging again another culvert. That one was not our fault, but it was a lateral line for sewage, and nobody kind of realized that. So when you get flexible asphalt and it's really, really, really hot, it becomes very pliable, right? So it's hard to control what the lifting of that asphalt does, especially if you're injecting too close to the surface. Company learned the lesson on that job. But we end up plugging this lateral line on one of our deeper injections. And so I dropped down into this, this manhole in order to unplug the polymer. And it was 3 things. A, really, really hot. We're talking about 119 degrees at 10 o'clock in the morning. It's 2 in the afternoon. It's like 130 outside. And I just drop into this sauna of a manhole. just all the water just expunges on me. To the point, guys, where like they dropped me down, we got all the confined space stuff or whatever, but the guys are up top dumping water onto my head while I'm trying to clear this lateral line. And so we're digging and going and pulling in water and everything's tough and I'm getting frustrated, whatever. And eventually I unplug it, and I already gave you the punchline for this one. Sewage, and backed up sewage that now has pressure. So by the time I get the polymer out, and sewage just sprays all over me. It was gross. It was so gross. And so the guys pull me up, right? And I come out just sweating and stinking. It's like 125 still outside, but it feels like a cool breeze because they dropped the thermometer on the inside of the culvert. It was like 150 or 160 degrees. It was bad. It's a bad job. Guys, I've got a million stories, right? I've been doing this upwards of 20 years at this point, from trying to float a boat and pull it off of a rock jetty during high tide, to exploding runways and other fun stuff, like just crazy wild stories. If you guys have stories and you're actually paying attention to these videos or whatever, drop me some lines. I'd love to hear other people's experiences, and see just, I don't know, commiseration or whatever else, right? We've all had difficult clients. We've all had difficult projects. We've all had the pristine things that go exactly like they should. And I don't know, even every once in a while, I've worked for an employer before who's like, roll the dice, worked great. Or roll the dice, and what do you think was gonna happen, right? So it's part of why I love this industry. It's part of why I love working with polymer and doing what I do, and it's part of why I want to get even deeper into the engineering part of everything. So again, if you got any stories, questions, comments, concerns, drop a line below or message me privately. Please like, share, subscribe. I just wanted to share some of those wild little stories with you guys. Thanks so much. Hope it put a smile on your face for today, and I'll catch you guys later.